This question is one of the more challenging linear equation ones, okay, because of the fact that it's decimals. That adds a new aspect to it. So just to go through it then, so we are told that line 1 is y equals 2.5 x plus k, and it goes through a point A which is at 3 minus 2. Okay. Now my tip is to always change decimals into fractions wherever possible when we're doing gradients. So we've got y equals now 2.5 is 5 over 2. Alright, so we've got 5 over 2x plus k. Are you okay with how I got 5 over 2?
You switched it?
Well, I just thought of it as 2.5 over 1, and I can't have a decimal in a fraction because a fraction is a decimal, so I can't have both. So what I did was multiplied by 2 like you would do any other fraction, and it becomes 5. 2.5 is times 2 is 5 over 2. Right? So I turned in, and that makes it nice and easy, especially in this situation. So I'm asked to find the value of k, so I've got to use these values. So I know that it's the x and the y value, so I'm going to say it's minus 2 equals, so there's the y value, equals 5 over 2 times the x value is 3, so that's that one, plus something. So if I do that, I've got minus 2 equals 15 over 2 plus k. Alright? So I've just got to figure out what I would do now. Now in this stage, you may actually think it was easier in decimals. So if I think of it as minus 2 is still 2.5 times 3 plus k, that would be minus 2 is 7.5 plus k. Now a lot of people got to this stage no problem, but you had to subtract 7.5 from both sides. So we've got minus 2 subtract 7.5 is actually minus 9.5, and that equals your k value. Right? So quite a few of you got, I think Messiah, you even got it and then scribbled it out and added another minus into your equation because you didn't think it could be a minus, but it can be a minus, right? But you'd lose one of those marks. So is that okay so far? All right. So I have used it in the decimal format here, but for the next part it says the line is perpendicular. So perpendicular lines are at right angles, and we know if the gradient, the m value of this line is, well in this case it was 2.5, but I changed it to 5 over 2. Now this one, I think a lot of you recognised it's negative reciprocal, so a lot of you put negative 1 over 2.5. Okay? But you can't have the decimal as part of the fraction, can't give it to you. There was only one mark for it, you're not allowed. So actually if I look at the 5 over 2, it becomes negative 2 over 5.
So the negative 1 over 2 is wrong?
It's not wrong, but it doesn't, you can't get the mark for it. Because you have to have said, if you do that, you have to then do times 2 to get rid of the decimal.
So
you can't have the decimal in the fraction. Yeah. So you can get away with it when it's just the decimal, but if the decimal's underneath on the fraction, you can't have it. Yeah. Alright, so then we've got to find the...
I don't understand why.
Go on.
Why negative reciprocal.
That's the rule for perpendicular gradients. So we have to find the equation. So we now know it's y equals minus 2 over 5x plus something. I'll say plus c. We know it also from the question goes through point A again. So we know it goes through 3 minus 2. So we actually just repeat what we did beforehand. So we've got minus 2 equals minus 2 over 5 times 3 plus c. So that gives me minus 2 is minus 6 over 5 plus c. Alright. Now, however you want to do this, you can convert that to a decimal.
And can go on number 2? No, let's see. Go on, based on what was B? B is that blue part?
Yeah, b's that gradient. Yeah. That's the gradient of the perpendicular line, part B.
One second.
So at this stage then, we've got to solve this. Now you can convert that to a decimal if you like. You've got a calculator. For me, I changed it into a mixed number, so I know that's minus 1 and 1/5. And the reason why I did that is because I know to get from minus 1 and 1/5 to minus 2, I just have to minus another 4/5. But you could have it as, was it minus 1.2 if you converted it to a decimal, and then you minus another 0.8, however you want. So if I had it as a decimal, it'd be minus 2 equals minus 1.2 plus c. So I would, yeah. So I've either got minus 4/5, or if I did it this way round, I'd have minus 0.8. So that gives me the part C of my equation. So to finish that off, I would have y equals, that was the gradient of the line from part B, so minus 2 over 5, or if you were doing it as decimals, minus 0.4 x, and then it's either minus 4 over 5 or minus 0.8, depending on what you do. So that's your part C. Okay with that at this stage, or? Okay, so the final bit then, is to write it in the form ax plus by plus d equals 0. Now, for this situation, I've either got y equals, what do we have, minus 2 over 5x, is it minus 4 over 5? Or I've got y equals minus 0.4x minus 0.8. So depending on how you've done it. So I'm doing both ways so you can see which one's easier. See, I would suggest having it as the fractions is much easier, because you are told, and this is one of you fell foul of this, that A, B and D are elements of the set of integers, which means they have to be whole numbers. So you can't have decimals, you can't have fractions. So the first job is to get rid of those. Now, I would say when you look at fractions, the easiest thing to do, well, if it's 2 over 5, 4 over 5, I multiply the whole thing by 5. Gets rid of the 5's. So then I have 5y equals minus 2x, because you get rid of the 5, leave just the minus 2x, and you have minus 4. Now, how do I do it here with decimals? It's actually, how do you see that you still have to times by 5, but how would you work it out? So you can see how the fraction, in this case, again, in this case the fractions are easier to use than the decimals. And then once I've got to this stage, I've just got to put it in the form all on one side, 0 on the other. So I just add my 2x, add my 4. So I've got 5y, add 2x, add 4 equals 0. And that's how we put it in that form. Okay.
But you have to put it.
Make sense of that? Now, if it was this one, I might get to the stage of doing y plus 0.4x plus 0.8 equals 0. So you've kind of done half of it. But then the question is, what would you do? How would you get from those decimals to whole numbers? Any ideas? It's just going to have to be a multiplied by something. We know it's multiplied by 5, but how would you actually, if you were going to work in decimals, how would you get that for yourself? It's quite difficult, actually. It's kind of, you'd have to do a bit of trial and error type thing. Right, you kind of have to find the lowest common multiple of 0.4 and 0.8 and keep kind of, you know, so you can see how it's easier to use the fractions, much easier. Right. So in this question, easier to find the gradient, fraction. Easier to find the final thing, fraction. I think the only time it was easier to use the decimals was to find k in the first place. But we could have found it using fractions as well. Now,